Hey guys, today we're going to be talking about the difference between accuracy, precision, and maybe get into a little bit of estimation. Here we go. Oops. So, accuracy versus precision, you might think of these two things as the exact same. However, they're just a little bit different. Accuracy is based on the quality of your equipment. So that means that you're going to get an answer close to the correct answer. Go ahead and write that down, please. Precision is the quality of your technique, and this is the idea that you're going to get consistent answers. So go ahead and write that down. Keep in mind here the difference between accuracy and precision. In both cases, we don't know what the actual answer will be. Something can be accurate and precise, something can be accurate but not precise, or something can be precise but not accurate. Let's start with precise but not accurate. Let's say you're measuring a piece of paper and you keep getting the measurement 12 inches. You do it over and over again and you get 12 inches. But the actual measurement is 11.5. So maybe in this case, you're using the ruler incorrectly. Maybe you're not holding it the correct way, or you've got the paper angled in some way, and that's why you're getting the wrong answer. But you keep getting the wrong answer a bunch of times. That would be something that's precise but not accurate. Something that's accurate but not precise is maybe you're using like a beaker to measure water, and you can it's kind of hard to see with the beaker because it's so wide exactly how much water's in there. So if you look at all the different times you've measured water, they're kind of all over the place, but for the most part they tell you what it is, except maybe just with not as many accurate digits or something like that. Here's two pictures. One is a very expensive scale, one's a very not expensive scale. Go ahead and tell me which one is which. Hopefully you chose the one on the left as the more expensive scale. This one can read grams down to the thousandths or 10,000ths place. So you'll see it says 198.3065. So yeah, that's 4 decimal points that it can tell you exactly how many grams it is. Versus this guy over here only has 2 decimal points. So the idea here is the more digits you have, the more accurate your measurement is. And then if you get a bunch of digits that are all very close to each other, that's precise. So again, kind of the difference there. Okay, so the question is, which would you rather use for 10.002 grams? Think about it for a second. Cool. The correct answer would be this guy over here, the one on the left. This is the only one that can measure it down to the 10,000ths place, so this is the only one you're going to want to use. You couldn't use this scale over here. You would read 10.00, but you wouldn't know what those last 2 digits are. So this scale over here, more accurate. Which would you rather use to measure 5 milliliters of water? Pick between the 50, the 25, or the 5, and then think, which would you rather use to measure 36 milliliters of water? Okay, for 5 milliliters of water, you definitely want to pick the 5 milliliter graduated cylinder, just because you can kind of see more clearly where the water line is. For 36 milliliters of water here, you've got, I don't know, I could see you saying 25, but the better answer is 50 because you could fit it all in one go. If you had to use the 25, you'd have to fill it up twice, which at that point, why not just use the 5 milliliter graduated cylinder? In any case, if you have to fill up a graduated cylinder more than once, that means you're dumping it out. And when you dump it out, there's going to be water left over inside the graduated cylinder. So that's where error can come from. So 5 milliliter and 50 milliliter are the answers. Okay, some terms to know, accuracy versus precision. Here's how this is going to look. We're going to show you 4 targets, and you're going to have to tell me for each one, is it accurate? Is it precise? 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 Go ahead and try these out now. Okay, for the first one, this one is accurate and precise. These X's are all close to the center, and they're all close to each other. So accurate because they're all close to the center, precise because they're all close to each other. For the second one, it's neither. It's not accurate and it's not precise. These X's are not close to each other, and the average of the X, they're not close to the center. For number 3, we would say it is both accurate, it is accurate, because if you look at where the average of the X's is, that's right in the middle, but it is not precise. If you look, it's hitting it all around the outside. For this last one here, it's going to be precise, but not accurate. Not accurate because it's not hitting the center. Precise because they're all close to each other. So hopefully you can see the similarities between taking good measurements as the center of the bullseye and then taking measurements that are close together as marks hitting close to each other. Hopefully that makes sense. What we're going to do now is we're going to show you these 4 situations except with data. So this is density of water. This blue line represents the true density of water at all points. This would be accurate and precise. All 4 dots are right on the line. Not accurate and not precise. Notice how these 4 dots don't follow any sort of trend whatsoever. For accurate but not precise, notice how some dots are above the line, some dots are below the line. This is kind of what your data will look like. Hopefully it'll be mostly accurate and it'll be mostly precise, but you'll probably have some dots that fall above and below the line when you do this in an actual experiment. Depends again on how accurate your measurements are. And then for the last one, not accurate but precise. Here you'll notice that every single dot is the same distance above the line. This is kind of concerning data if we were to see this in an actual lab. I would think that maybe there's something wrong with the way you took your data. Maybe, for example, in this case, you were measuring water, but there's 6 grams every time. So maybe the cup was something you were also measuring, whatever the water was in, and that threw off all the measurements by an even 6 grams every time. Last thing we have for you guys today is estimation. How can we estimate large numbers? Go ahead and take a moment, try and figure out how many numbers, how many little blocks are in here. Hopefully you got the number 80. It's 10 by 8, so hopefully you just counted 10 across, 8 down, and multiplied them. Not every estimation problem will look nicely like this. Oftentimes, sometimes there'll be a bunch, kind of a mess. And in this case, again, if you count, you can see it's 10 over, 8 down, and you can still kind of estimate this to be about 80. So how this comes into play is this is a great way to kind of check your answers, make sure they make sense. So if you have a number like 989 and you're multiplying by that by 9, that's roughly the same thing as 1,000 times 10, kind of rounding those 2 numbers. So you should expect that your number 989 times 9 should be about 10,000-ish. So this is a great way when you're doing experiments just to say, am I getting answers that look about right, or are these totally wrong? Okay guys, that's all I have for you today. Thank you so much for watching and have a great rest of your day. Take care.